Today I want to go over this most egregious video I've ever seen when it comes to just disinformation about retrogrades, about Kepler, about astronomical history in general. It's by Welch Lab. The premise of this video is supposed to be about Kepler working with Tycho Brahe to map out or calculate the orbit of Mars because it has such a strange orbit. This just sets the table for what's coming.
Some believe that the motions of Mars and the other planets were a result of his own model of the solar system, where the Sun orbits around the stationary Earth, and the planets orbit around the Sun. But
Tycho, you didn't die in vain, and I will not let this vein of comedy go unmined either.
When Mars is close to the Sun as it sets or rises, the planet moves quickly from west to east. However, over time, Mars and the Sun drift apart in the sky, with Mars rising in the east as the Sun sets in the west. As Mars moves further from the Sun in the sky, its night-to-night wanderings become stranger. It changes its mind on the whole west to east thing, slows down, stops, goes backwards for a while, and then continues on as if nothing happened.
Okay, so he's using stellarium to show the retrograde of Mars. He doesn't say when this retrograde is, but clearly it's stellarium. So let's fast forward a little bit in the video and let's see how he explains retrograde happening.
Under the heliocentric model, retrograde motion has a much simpler explanation. Since the Earth orbits the Sun faster than Mars, when Earth approaches and overtakes Mars, the planet appears to temporarily move backwards against the background of stars. This is why the motion of Mars is connected to how close it is to the Sun in the sky. When Mars appears close to the Sun, we're seeing it across the solar system, and Mars appears to be moving more quickly because it's headed in the opposite direction of Earth.
Now, anytime somebody like this guy wants to sell you something, he'll use stellarium when it's convenient, but when it doesn't work the way he wants it to work, he'll resort to these corny animations that show the retrograde happens somewhere out in the distant stars. It's an optical illusion. But let's help this guy out. Let's do a Mars retrograde in stellarium and prove that through right ascension and declination, we see Mars' actual movement doesn't have anything at all to do with us passing on the inside lane. It actually is a function of the trochoidal pattern because of the orbital arrangement, and the loop itself is what we're actually seeing. So here I have a retrograde of Mars, and it is 2063. We're going to begin the retrograde at March 11th. Let's let it play just so you can see how it looks. Speed it up there. Moon's coming into the picture there. Speed it up a little more. Now you see the pattern. I'll run it in reverse just to see it go the other direction. And then we're back to the beginning. Now, as I said, they don't want to use stellarium to show anything that's contrary to their dogma. So, as we can see, here's the ephemeris for that retrograde, and that's the pattern in the yellow there. It begins on the 11th of March 2063. You can see the right ascension and declination is given. The distance in AU is given. Of course, the elongation is there as well. So, and just so nobody thinks this isn't Mars, there it is. Okay, so let's step through this. So we'll go, this is every 10 days. So 10 days later, Mars has changed its declination and right ascension. And you can see it's getting closer to Earth. And as I said before, the loops always occur at the nearest, closest to Earth. It's perigee, and it has to happen that way because it's Earth-centered. So the center of the parent body is Earth. It means the Sun orbits Earth, and Mars orbits the Sun. Mars has a larger orbit than the Sun's. So Mars is a very peculiar orbit, and that's why Kepler did not have the mental facility to figure out what was going on, so he faked the data. So we'll get back to that in a second. But so here we go, 10 days more, 10 days further. As you can see, the declination and right ascension updates. The distance is shrinking, and we keep going. So now we're at April the 20th, 2063. Mars is coming a lot closer to Earth, and by the same token, the magnitude will increase as well. The brightness will increase, clearly because the planet's nearing us. So there you have April 30th, May 10th, and that is probably almost as close as it will be. Looks like looks like May 20th is going to be the closest. Now I have this every 10 days. There may be a closer point, but there may be a closer point in between those two, but I've only got it for 10 days just for simplicity because this chart got really big. It was hard to see it on the screen. I had to zoom that out a lot. So right there you can see the distance is 0.527081 AU, and you can see the coordinates. So there it is. The ephemeris shows that Mars is actually moving in the sky. It's not an optical illusion. It's gone one direction and then gone back the other direction. So you can clearly see that on the right ascension and declination. Now, this is a equatorial view, and that just means like if you had a tracker on a telescope, that's an equatorial view. Now, when you're seeing this as an observer, you're not going to see that east-west motion. You're going to see a north-south motion. Let me just flip over to show you. That's what you're going to see, and that's why the right ascension doesn't really change much, because it's sort of a vertical phenomenon. It's not really the phenomenon that we see when we turn the equatorial mount on. It's the same, but the orientation is just shifted 90 degrees. So we'll keep going. Mars is about to come out of retrograde and start heading back prograde. That's going to be really the end of the retrograde cycle now. We'll come back and he's headed back the same direction as the Sun. And as we can see in stellarium, the right ascension and the declination don't lie. There's no fairy tale path that's out in the distance, that's some optical illusion. The planet really did move. If we go ahead and animate this, we'll see that the loop is tight. The loop's a very in and out motion, but the orbit itself is a very circular motion. It moves away with a smoothness because it's headed back away in a long arc. As it's in its orbit, it's the circumference of where it's moving, versus the tight loop where it's kind of an in and out movement. I'd like to end this video by taking a look at the Tychosium, which is the Tychos model animation program programmed by Patrick Holmquist, along with Simon Shack, who wrote the Tychos book. It's a slight modification to the Tycho Brahe model. Of course, Simon did add the motion of the Earth, but this is perhaps, not perhaps, this is absolutely, beyond a shadow of a doubt, the best online animator that you will ever see. What we're looking at here is the very same Mars retrograde we were looking at earlier. The one in 2063. So without further ado, let's just run it. That is amazing. You will not find any other orrery that will do anything close to that. And I'm just changing the angle so we can see the path that Mars took. You can go over here, go to planets. Let's just turn off Earth. We can see the pattern that we can see the loop Mars made. Now let's turn. Now let's take a top view. It's just by far the best animator orrery that you will see on the anywhere at all. So let's up here you can go backwards by clicking these buttons. Change the time. I'm going to change it to months. Let's step backwards. And let's take a look at the same retrograde from a top view. There you have it.